Hi everyone, this is Mrs. Parr, and on this episode of Math Up to Par, we are going to be talking about benchmark fractions and how we can use benchmark fractions to help us compare and order fractions. So when we think about benchmark fractions, we're going to think about them in relationship to 1/2, okay? Half of the parts that we are counting. So do we have a fraction that's close to that halfway mark, or do we have one that's more than half or less than half? Sometimes we'll notice that fractions are kind of in between and don't fit perfectly into these categories, and that's okay. The purpose of this is to begin thinking about how fractions relate to each other. Even though they have different numerators and denominators and different size pieces, if we think about them in relationship to 1/2, we can begin to kind of compare them without using strategies such as cross multiplication or something else, because we can understand how they relate to 1/2, okay? So I'm thinking close to 1/2, right? If I look, I've got a bunch of fractions jumbled over here, but 2/4 is equal to 1/2, okay? Half of 4 is 2. So that's actually an equivalent fraction to 1/2, and we'll talk more about equivalent fractions in my other video. I also know that 5/10 is equal to 1/2 because half of 10 is 5. Now, not all of these are going to be perfectly close to 1/2, but these two are exactly equivalent because half of 4 is 2 and half of 10 is 5. Anytime the number in the numerator is half of the denominator, then that fraction is equal to 1/2, okay? Let's look at some of our numerators that are smaller, okay? For example, 1/6, okay? 1/6 is less than half. I know for a fact because half of 6 is 3. 6 is an even number. So half of 6 is 3, so one of those pieces is less than half. It's actually closer to 0 than it is to 1/2. So I'm going to put this one in this category over here. I see another fraction with a denominator of 6, and this one has a numerator of 5. That means all but one of the pieces we are counting. This one is definitely more than 1/2 because just like we said earlier with our 6, half of 6 is 3. So 5 is significantly more and 1 is significantly less. So just by looking at those, I can see. I now know that if I was comparing 5/6 to 2/4, I would know that 5/6 is greater than 2/4 without doing any sort of multiplication because I know that 2/4 is close to 1/2 and this one is significantly more than 1/2. So I can do that without showing any cross multiplication. I could use that to check my work. But because I understand how these fractions relate to 1/2, I'm going to better understand how they compare to one another. And likewise, I can see that 1/2 is less than 2/4 because of the category that it falls in. If I'm looking over here at 4/7, so 7 is an odd number, meaning I can't split 7 in half. And I wouldn't be able to split 7 in half unless I were able to break it into smaller pieces, which I'm not going to do. So if I take 7, if I have 7 pieces, 7 total in my denominator, if I have 4, that means what's left over is 3. Well, 3 and 4 are 1 away from each other. So 4/7 is slightly more than half, and 3/7 is slightly less than half. But because they're right on that edge, we're going to say that this is close to 1/2 because it's not saying it's equivalent to 1/2. It's not exactly, but it's close to 1/2, which is why I'm going to put that in this category right here. Now, I have 1/4 and 3/4. Okay, so just like I looked at my 6, I'm going to look at my 1/4 and my 3/4. Okay, I know that 2/4 is equivalent to 1/2. Okay, so that means that 1 out of 4 is less than 1/2, and 3 out of 4 is more than 1/2. Okay, so I would now be able to compare 3/4 to 5/10 or 4/7 because I know these are close to 1/2, but this one is more. And I'd be able to compare 1/4 to these other fractions because I know what category it falls in. Let's look at 7/8 right here. So we have 7/8. We actually have 3 different ones with 8s in them. We have 7/8, 2/8, and 3/8. Okay, so when we look at these, they all have 8 total pieces. Well, half of 8 is 4. Okay, so we don't have a 4/8, so we don't have one that's going to be, we don't have one of these that's going to be exactly equivalent to 1/2. We know that 7 out of 8, 7 is significantly more than 4, especially in relationship to 8. And 7/8 is only one piece away from being one whole, just like my 5/6 and my 3/4. So I know that this one goes under my more than 1/2 category. So now we have 2 and 3. Okay, these are very close to each other. We know that they're both less than half. Okay, and we can confidently say that 2/8 it's 2 less than half. So I would go ahead and put this in this category over here, the less than half category. 3/8, it's less than half, but 4/8 would be half. So 3/8 is just one away from half. So even though it's less, I might put it over here in the close, and you might have it kind of on this line because it's technically less, it's technically close, but you know, these categories are not, they're not all going to fit perfectly, especially when you're thinking about the definition of what is close to a half. But if I put this here, it'll remind me, okay, I might need to kind of think through this one a little bit more if I'm comparing 3/8 to one of these in these categories. Now we have 8/10. Okay, 8 is 2 away from a whole, which would be 10 out of 10. So we're going to say that 8/10 is more than 1/2. And then we have 3/12. Okay, well, so half of 12 is 6. 3 is half of that. So that's going to be closer to less than a half. Okay, so here's where we have them split up right here. So now we've kind of looked at them in categories. We're going to look at these same fractions, but we're going to kind of put them on a number line to see how close they fall together. So I see 2/4 right here. That is equivalent to 1/2. So I'm going to stack that right here because I have my halfway mark, I have my closer to 0 mark, and my closer to 1. Now, these are not going to be perfect. They're not going to be in their exact right places, but it's going to help me think about how they fit in relationship to one another. All right, so we saw here we have the 4/7. Oh, we also have 5/10, and 5/10 is also equal to 1/2. So I'm going to kind of stack these right along the line. So we have straight down. So these are exactly equivalent. So these should fall right in order. These are all equal to each other if I were to be comparing. My 4/7, remember we said 4 was a little bit more than half. So this one is going to kind of fall just a little bit above half here. So this one is slightly more than this. So if I knew I was comparing these two, I would know that 4/7 is greater than 2/4. Here's my 6 that I talked about earlier. 1 out of 6 pieces is fairly small, right? And so if I'm I know it's somewhere in between 0 and 1/2, it's probably closer to 0. I think about this halfway point right here. These halfway points actually represent 1/4 and 3/4. Okay, so this is 1/4 and this is 3/4 right here because 2/4 is equal to 1/2, and this number line is actually split into 4 pieces. So we have 1, 2, 3, 4. So this line is exactly 3/4. This line is exactly 1/4. This line is exactly 2/4. When I think about 1/6, okay, this is, you think about it and you have this half right here. So this is half of the half, right? So this is the halfway point in between 0 and 1/2. Well, if I have 3 out of 6 is equal to half, then 2 out of 6 might be a little bit right here, but then 1 out of 6 is probably going to be closer down here. So this isn't an exact part, but I'm going to put this one right around here. And if I have others that are close to it, then I'll compare them when I get there. I also know that because these have the same numerator, they both have 1 in the numerator, 1 out of 4, those 4 pieces are going to be larger than my 6 pieces. So 1/4 is larger than 1/6. So I don't maybe know exactly where this one fits, but I do know that it's less than 1/4. So I'm going to put it over here for now. My 5/6, just like with my 1/6 in relationship, I know that it is only 1 away. So from a whole, because 6 out of 6 would be equal to 1 whole. So 5/6 is probably somewhere around here, somewhere close to this. Okay, so I'll go ahead and put this one at the bottom. So we have a few more. Let's look. 2/8 is actually equivalent to 1/4. Because when I simplify this fraction, I get 1/4. If I multiply my numerator by 2 and my denominator by 2, I get this fraction, which you'll see if you are looking at my video on equivalent fractions. But I know that this half of 8 is 4, so 4/8 would be in the middle. And then like you take 4 and the half of 4 is 2. So this is like the halfway point to my halfway point. So 2/8 kind of fits down here. Then I have my 8/10, which is probably going to go somewhere over here. I don't quite know. Let's see, 8/10 and 5/6. Well, 8 is 2 away from 10, but the pieces are smaller for my tenths, and 5 is only 1 away. So these are probably pretty close to each other. So I would probably check these with cross multiplication, but I am going to estimate that this is slightly less than 5/6 because it's 2 away from 1 whole instead of 1. But the pieces are different sizes, so I probably would want to go back and check my work. These are probably going to be pretty close to each other in terms of their amounts. I have 7/8 right here, which is 1 away. But if I'm thinking about it in relationship to 5/6, okay, we have 5/6 and 7/8. Each one is 1 away from their denominator, but these pieces are going to be smaller. So this one's actually going to be a little bit closer. So I'll move these down slightly. I'm thinking that 8/10 is the smallest, then 5/6, then 7/8. I know for a fact these two because they're each 1 away from their denominator. And when you have that, the one that's got smaller pieces, the larger numbers, those are going to be closer. So I can compare those, but I would probably want to check my work slightly with these. These two are both less than half. We talked about 3/8 on the other column being kind of in between 0 and 1/2 because it's close. It's less than half because half of 8 is 4, but it's not really that close to 0. So I know 2/8 is right here, so that means 3/8 is kind of going to fall right here on the other side. It's not going to be quite as close to where my 4/7 is, but these are kind of around the same area, okay? And then when I look at 3/12, okay, well, 3/12, half of 12 is 6. And you take 6 pieces, okay, well, that means there would be 1/12, 2/12, 3/12, 4/12, 5/12 on this side. 3 is kind of that halfway part. So 3 is actually equivalent, 3/12 is equivalent to 1/4 and 2/8. So if I look at these in groups, I see, okay, these are kind of all closer to 0. These are similar to 1/2, or they're kind of close to half. And these are close to 1 whole. Now, like I said before, this isn't a perfect representation, but when I start to take my knowledge of fractions and relate them to these benchmark numbers of 0, 1/2, 1 whole, then I am able to think through the sizes of these fractions and what these numbers actually mean. It's not just a numerator on top of a denominator, and there are so many other strategies that you can use to compare fractions. So benchmark fractions is a really, really powerful strategy to use. So I could say easily to you, okay, well, 1/6 is less than 4/7, or 3/12 is less than 4/7, or 2/8 is less than 5/6, or 2/4 is less than 7/8, or 3/4 is greater than 5/10, or 1/6. Can use this visual to compare the fractions without doing any sort of cross multiplication. That doesn't mean cross multiplication isn't a powerful tool to check your work, because it can be, but understanding how fractions fit together and relate to one another is such a powerful skill. So thanks so much for listening and happy practicing. Bye.